We shall go for the questions on forward difference formula. Question is apply Newton's forward difference interpolation formula to find y at 1.4 given the data. X values are 1, 2, 3, 4, 5. Corresponding function or y values are 10, 26, 58, 112, 194. Here you can see that x values are equally spaced. Spacing between adjacent x values are equal to 1. Spacing between adjacent x values means you have to see the succeeding value minus preceding value. 2 minus 1 is 1. Then 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. So all that x values are equally spaced. Spacing between adjacent x values, which is taken as h, will be equal to 1. Now before you go for the formula, construct the table first. Looking at the table, we can make out formula to be written up to which term. So in the table, first two columns are always given x and y values. Now that from the third column onwards, we construct the differences of different orders. So third column will be first order difference. So while calculating the entries of the third column, you look at the entries of the preceding or the previous second column. From the entries of the second column, you have to calculate the succeeding value minus preceding value. 26 minus 10 is 16. Then 58 minus 26 is equal to 32. Then it is 112 minus 58, which is 54. Then we have 194 minus 112, which is 82. These are the entries of the first order forward differences. Then the entries of the second order forward differences, the entries of the fourth column. While calculating the entries of the fourth column, look at the entries of the third column. In the third column, again calculate succeeding value minus preceding values. 32 minus 16 is 16. Then 54 minus 32 will be equal to 22. Then it is 82 minus 54, which is equal to 28. These are the entries of second order forward differences. Next is the third order forward differences or third differences, which is again look at the entries of the previous fourth column. In the entries of the fourth column, calculate the succeeding value minus preceding value. So it is a 22 minus 16, which is a 6. Then it is a 28 minus 22, which is equal to 6. These are the entries of the column third order differences. Then the fourth order differences, again look at the entries of the preceding column, which are the entries of the third order differences. From that column, succeeding value minus preceding value. 6 minus 6 gives 0. So we have the table up to the column containing fourth order forward differences. And the fourth order forward difference is 0. So you can use the formula up to the term containing third order forward difference. In the formula, whenever we use Newton's forward difference formula, in the formula we are going to use the entries which are in the topmost, which are the topmost entries of each column. So if we see the column y, then delta square y, delta cube y, topmost entries. So y naught is 10, delta y naught is 16, delta square y naught is 16, delta cube y naught is 6. Delta power 4 y naught is 0. Since it is 0, we need not use it in the formula. So write the formula first. Y will be equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into delta square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y naught. Here instead of a p you can use a r. Doesn't matter if we change the letter, whether it is a p or r, answer will not be changed. Answer remains the same. So instead of p you can use it as r. So here we have used it as a p, and p is x minus x naught divided by h. X means that value at which you have to calculate y value, which is 1.4. X naught means the first x value or the topmost x value, which is 1. H means the spacing between adjacent x values, which is 1. So p will be x minus x naught by h, 1.4 minus 1 divided by 1 or equal to 0.4. So once you get that value, along with that value, use the value of delta y naught, delta cube y naught, delta square y naught, etc. Use it in the formula, then calculate. You get the required answer for y. Then you can go for the second question. Use Newton's forward interpolation formula to find y at 35 given. y20 612, y30 is 539, y40 446, y50 343. Here the suffix represent x values. So the x values are 20, 30, 40, 50, which are equally spaced. Spacing between adjacent x values is 10. H will be 10. You are asked to find y at 35. When x is 35, you are asked to calculate y value. So first construct the forward difference table. First two columns are x and y values, which are given in the question. Next value is the first order difference. So to calculate the entries of first differences, you look at the entries of the previous column, entries of the second column. In the second column, you calculate succeeding value minus preceding value. So it will be 539 minus 612, which is minus 73. Then 446 minus 539, which is minus 93. Succeeding value minus preceding value, 343 minus 446, which is minus 103. These are the values of first order difference. Similarly, second order difference denoted as delta square y. To calculate the second order difference, you look at the entries of the previous column, the entries in that first order differences. In that column, you go for succeeding value minus preceding value, minus 93 and minus of minus 73, which gives minus 20. Minus 103 and minus of minus 93 plus 93, minus 103 plus 93 is minus 10. These are the entries of second order differences. Then go for the third order differences. While calculating the third order difference, look at the entries of the preceding second order difference values. In that you go for succeeding value minus preceding value. So it is minus 10 and minus of minus plus 20, which gives 10. So we have the entries values up to third order differences. From this table, you have to take only the values which are at the top of the column, topmost values of the columns. So here we will be using y naught, which is 612, delta y naught minus 73, delta square y naught minus 20, and delta cube y naught, which is 10. So these values we are going to use. Then write the formula of the forward difference up to the term containing delta cube y naught. So it is y will be equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into delta square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial same as 6 into delta cube y naught. Here p means x minus x naught divided by h. X is that value at which y value is to be calculated, 35. X naught means it is 20. And h means the spacing between adjacent x values, which is 10. So 35 minus 20 divided by 10 gives 1.5. Substituting all these values in that forward difference formula, then the rest is calculation, which gives y value, the required y value at x is equal to 35 as 494.375.